I'm so glad you found your way here. The ground beneath you right now has been shaking, flowing, and transforming for over 4 billion years. Tonight, you'll discover how Earth's powerful forces shape our world and understand why disasters are simply our planet breathing, stretching, and renewing itself. Welcome to Nature Sleep Stories. Wherever you are right now, feeling solid ground supporting your body, or sensing the stillness of the air around you, allow yourself to rest in Earth's ancient rhythm. We'll discover 100 nature facts about our planet's forces, from plates grinding beneath oceans, to storms gathering moisture over warm seas, to mountains rising one grain at a time through patient centuries. These calm explorations of Earth's wisdom plant seeds of tranquility in restless hearts. Sharing this gentle science creates a pathway for more nature lovers to discover this healing ground, one sleepy soul at a time. Your presence here nurtures our growing forest of peace. Sink into your favorite resting spot. Allow your muscles to release, each breath growing softer. There's no need to remember these geological facts. Just notice that warm, drowsy calm washing over you, like gentle ocean waves pulling back from shore, each one drawing you deeper into restful, effortless sleep. Close your eyes and breathe deeply. You're resting where ancient trees whisper secrets of eternal wisdom. Let your mind sink with nature's calm. And now we begin. Earth moves constantly, though you can't feel it. Right now, beneath your feet, massive plates of rock are drifting across the planet's surface at about the same speed your fingernails grow, roughly 2 inches per year. These tectonic plates have been moving for billions of years, carrying continents, creating oceans, and reshaping our world in slow motion. When these plates meet, they don't glide smoothly past each other. Instead, they catch and stick, building up tension for decades or even centuries. Eventually, that pressure releases in sudden movements we call earthquakes. It's not a disaster from Earth's perspective. It's simply how our planet maintains balance, releasing energy that's been quietly accumulating in the darkness below. Earthquakes happen about 50 times per day somewhere on Earth. Most are so gentle you'd never notice them. Small tremors occurring quietly in remote places, barely registering on sensitive instruments. The planet is always adjusting, always settling, like an old house creaking as temperatures change throughout the day and night. This gentle movement has been happening for billions of years, and will continue long after we're gone. Better warning systems, stronger buildings, and improved emergency responses mean fewer people are affected by nature's powerful forces than in previous generations. We've learned to read the planet's signals more clearly, to understand its rhythms, to adapt our lives to its ancient patterns. The ring of fire encircles the Pacific Ocean like a 25,000-mile horseshoe of volcanic and earthquake activity. About 90% of the world's largest earthquakes and 75% of active volcanoes concentrate along this boundary, where several massive tectonic plates meet. Countries like Japan, Indonesia, Chile, and the western coast of North America sit within this active zone. But here's something remarkable. People have lived in these regions for thousands of years, building cultures, raising families, creating art and music, all while the ground occasionally trembles beneath them. They've learned to exist alongside Earth's rhythms. understanding that these forces aren't attacking them. They're simply part of living on a dynamic, breathing planet. The ground moves, and life adapts, continues, persists. Volcanoes are Earth's pressure release valves. Deep underground, temperatures reach thousands of degrees, hot enough to melt rock into a flowing liquid called magma. When this magma finds cracks or weak points in the crust, it rises toward the surface, driven by its own buoyancy. Molten rock is less dense than the solid rock around it. Sometimes it erupts dramatically, sending ash and lava into the sky. Other times it simply oozes out slowly, building new land grain by grain. There are roughly 1,500 potentially active volcanoes on Earth right now. Most sit quietly, decades or centuries passing between eruptions. They're not waiting to destroy, they're simply existing, part of the planet's natural cooling system, releasing internal heat that has nowhere else to go. Hurricanes are heat engines that form over warm ocean waters. When sea surface temperatures climb above 80 degrees Fahrenheit, water evaporates rapidly into the air above. As this warm, moist air rises, it cools and condenses into clouds, releasing heat energy in the process. This heat makes more air rise, pulling in more moisture from the ocean surface, creating a self-reinforcing cycle. In 2024, Hurricane Beryl became the earliest Category 5 storm on record in the Atlantic, forming on June 28th and reaching peak intensity on July 1st, a sign that ocean temperatures are changing. But hurricanes don't form to cause destruction. They're simply the atmosphere's way of moving heat from the tropics toward the poles, balancing the energy budget of our planet, maintaining equilibrium. The Sahara Desert received flooding for the first time in nearly 50 years during September 2024. More than 4 inches of rain fell in just 24 hours across parts of Morocco, an amount this region might normally see over an entire year. Images showed sand dunes transformed into temporary lakes, valleys flowing with rushing water. This wasn't a malfunction of nature, but rather an unusual alignment of atmospheric conditions. A cold front meeting warm, moist air in just the right way to trigger intense rainfall. Desert floods remind us that what we call natural disasters are often just rare, but natural variations in weather patterns. The desert wasn't being attacked. It was simply receiving water in an unexpected moment, a gift it couldn't absorb fast enough. Tornadoes form when different layers of the atmosphere move in conflicting directions and speeds, a phenomenon meteorologists call wind shear. In the United States, warm, moist air from the Gulf of Mexico often meets cool, dry air flowing down from Canada. When these air masses collide over the flat plains with no mountains to slow them, they can create rotating columns of air. In May 2024, a single outbreak produced more than 165 tornadoes across multiple states. Yet, despite this intensity, the spinning funnel of a tornado is typically only 300 to 2,000 feet wide. The vast majority of land, even in tornado-prone regions, will never experience a direct hit in any given year. Nature's power is selective and local. Floods are Earth's ancient way of distributing water and nutrients across landscapes. Rivers naturally overflow their banks during heavy rains or rapid snowmelt, spreading sediment rich in minerals across floodplains. For thousands of years, civilizations like ancient Egypt relied on these predictable floods to fertilize farmland. In October 2024, parts of New Mexico experienced rare flash flooding with rainfall rates of 1 to 3 inches per hour, transforming dry arroyos into raging torrents within minutes. Yet even in these intense moments, the water was simply following gravity's command, seeking the lowest point, carrying away what wasn't anchored, delivering moisture to thirsty soil downstream. The flood wasn't personal. It was just water behaving as water must. Landslides occur when gravity finally overcomes the friction holding soil and rock in place on a slope. Heavy rainfall can saturate the ground, adding weight and reducing friction between particles. In Papua New Guinea's Anga province during May 2024, torrential rains triggered massive landslides that buried entire villages under mud and debris. The soil had been there for centuries, held together by tree roots and internal forces. But as development removed forests and heavy monsoon rains added water weight, the balance shifted. The land didn't choose to slide. It simply responded to physical forces that had been building over time. Gravity pulled, friction released, and the hillside moved downward, seeking a more stable configuration. It's geology following the simple rules of physics. Nothing more. Lightning strikes Earth about 100 times every second, roughly 8 million times per day. Each bolt is a massive electrical discharge caused by the separation of charges within storm clouds. Ice particles colliding in the turbulent air create static electricity, with positive charges accumulating at the cloud's top and negative charges at the bottom. When the difference becomes large enough, current leaps between cloud and ground in a flash hotter than the surface of the sun. In 2024, a lightning strike in Croatia ignited a wildfire that was part of a 21% increase in wildfires from the previous year. Yet lightning has sparked fires for millions of years, long before humans existed. Those fires cleared undergrowth, renewed forests, and shaped ecosystems. Fire is as natural as rain. Droughts are simply extended periods when an area receives less rainfall than normal. In 2024, Zambia experienced its worst water shortage during the growing season in 30 years, prompting the president to declare a national disaster in February. The Kariba Dam, which provides 80% of the country's electricity, saw water levels drop so low that turbines couldn't operate fully. Yet, even in drought, Earth is just distributing its water differently, not losing it. The total amount of water on our planet remains constant, cycling between ocean, atmosphere, and land through evaporation, precipitation, and flow. During a drought, that water is simply somewhere else, waiting to return. It always returns, given time. The cycle continues, patient and inevitable. Wildfires in 2024 started earlier and burned longer than in previous years. In Chile's Viña del Mar region, fires in February destroyed homes in an area known for its cooler coastal climate. In Mexico's Baja California, April fires burned 500 square kilometers and destroyed 800 homes. Yet fire has been part of Earth's ecosystems for over 400 million years, since plants first colonized land. Some tree species, like giant sequoias and lodgepole pines, have evolved to require fire for reproduction. Their cones only open and release seeds after exposure to intense heat. What we call a wildfire disaster. The forest might experience as renewal, clearing space for new growth, returning nutrients to soil, resetting the cycle of life. Heat waves are extended periods of unusually high temperatures for a given region. Las Vegas in the summer of 2024 experienced its hottest 3-month period since records began in 1937, with average daily temperatures of 96.2 degrees Fahrenheit. During June through August, the city recorded temperatures that made even long-time residents struggle. Yet Earth has experienced far more extreme conditions in its past. During the Eocene period, about 50 million years ago, global temperatures were roughly 20 degrees warmer than today, with palm trees growing in Alaska and crocodiles living near the Arctic Circle. The planet didn't suffer. It simply existed in a different climate state. Earth has no preferred temperature. It simply is what its energy balance makes it. Storm surges occur when hurricane winds push ocean water toward shore, creating a dome of elevated sea level that can flood coastal areas. Hurricane Helene in September 2024 made landfall near Perry, Florida as a Category 4 storm with winds of 140 miles per hour. The surge of water it pushed inland moved with remarkable force, demonstrating how ocean and atmosphere work together. The water wasn't attacking the land. It was simply responding to atmospheric pressure and wind stress, piling up where forces pushed it, then retreating when those forces released. The ocean has no intention, only motion, following the physics of fluid dynamics and the commands of wind and pressure. Sinkholes form when underground water dissolves limestone and other soluble rocks, creating cavities below the surface. Eventually, the roof of these hidden caves collapses, and the ground above suddenly drops. Florida, with its limestone bedrock and high water table, experiences frequent sinkholes. They can open suddenly, swallowing cars, houses, even entire streets within minutes. Yet this dissolution has been happening for millions of years, slowly carving vast underground cave systems, creating underground rivers and lakes. The Mammoth Cave system in Kentucky has over 400 miles of explored passages, all carved by patient water over geological time. A sinkhole isn't earth-breaking. It's Earth revealing what has already happened below, making visible what was always there, just hidden. Tsunamis are waves generated when large volumes of water are suddenly displaced, typically by underwater earthquakes, volcanic eruptions, or submarine landslides. The 2004 Indian Ocean tsunami, triggered by a magnitude 9.1 earthquake off Sumatra, traveled across ocean basins at speeds up to 500 miles per hour in deep water, roughly the speed of a jet aircraft. Yet, in the deep ocean, these waves are often less than 3 feet tall, passing beneath ships almost unnoticed. Only when they reach shallow coastal waters do they slow down, compress, and grow to devastating heights. The wave isn't choosing to destroy. It's simply energy propagating through water, following the mathematics of wave motion. It travels because it must, arriving when the physics of distance and speed dictate arrival. Avalanches occur when snow accumulates on mountain slopes faster than bonds between layers can strengthen. In Afghanistan's Nuristan province during February 2024, heavy snowfall triggered avalanches that affected communities in the region. Each snowflake that falls adds microscopic weight to the slope. Temperature changes. New snowfall on old snow. The angle of the slope. All these factors determine whether the snow will stay put or suddenly release. When bonds break, thousands of tons of snow can slide downslope at speeds exceeding 80 miles per hour, powerful enough to snap mature trees and crush buildings. Yet the snow isn't falling with purpose. It's simply responding to gravity and friction, seeking the lowest point, following the path that physics demands it follow. Dust storms occur when strong winds lift particles of sand and dust into the air, sometimes creating walls of sediment thousands of feet tall. The American Dust Bowl of the 1930s, caused by both drought and poor farming practices, created storms so intense that soil from Oklahoma was deposited on ships in the Atlantic Ocean, over 1,000 miles away. In desert regions today, haboobs, intense dust storms common in the Middle East and southwestern United States, can reduce visibility to 0 in seconds, grounding aircraft and halting traffic. Yet the dust traveling in these storms is often rich in nutrients. Sand from the Sahara Desert regularly crosses the Atlantic to fertilize the Amazon rainforest, a gift of minerals that makes that ecosystem possible. Cyclones, hurricanes, and typhoons are all the same phenomenon. Tropical cyclones, just called by different names depending on where they occur. In the Atlantic and Eastern Pacific, they're hurricanes. In the Western Pacific, typhoons. In the Indian Ocean, cyclones. Typhoon Yagi in September 2024 brought torrential rains and storm surges to East Asia, causing widespread changes to the landscape with large areas temporarily underwater. Yet these storms have been forming for millions of years, long before humans built cities in coastal zones. They're simply Earth's atmosphere, balancing heat between the equator and poles, moving warmth from where there's too much to where there's too little. The planet has no mercy, but it also has no cruelty. It simply operates according to laws of physics and thermodynamics. Blizzards combine heavy snowfall with strong winds, creating whiteout conditions where visibility drops to near 0. In January 2024, back-to-back blizzards struck the northeastern United States, dumping several feet of snow and bringing wind chills far below 0. Transportation halted. Power lines fell under the weight of ice, and entire regions came to a standstill. Yet this same snow, when it melts in spring, will fill reservoirs, feed rivers, and water crops through summer. Snowpack in mountains acts as a natural reservoir, storing winter precipitation and releasing it gradually as temperatures warm. The blizzard that strands travelers in January becomes the water that irrigates farms in July. Nothing in nature is wasted. Every force serves multiple purposes in the grand cycles of the planet. Hailstorms occur when thunderstorm updrafts are strong enough to keep ice particles suspended in the cloud, allowing them to grow layer by layer as supercooled water freezes onto them. In May 2024, Texas experienced hailstones the size of golf balls, damaging vehicles and infrastructure. The largest hailstone ever recorded in the United States fell in South Dakota in 2010, measuring 8 inches in diameter and weighing nearly 2 pounds. Yet these falling ice chunks aren't attacks. They're simply frozen water that grew too heavy for the wind to support any longer. Gravity prevailed, and the hail fell, following the same force that makes every object on Earth's surface stay put. Hail is just frozen rain, given unusual circumstances to grow large before falling. Ice storms occur when rain falls through a layer of freezing air near the ground, coating everything it touches with a layer of ice. Trees, power lines, roads, and buildings become encased in crystal shells. In December 2021, an unusual ice storm affected parts of the central United States, bringing down power lines under the weight of accumulated ice and leaving millions without electricity during freezing temperatures. Yet that same ice, catching sunlight after the storm passes, transforms landscapes into glittering wonderlands, every branch coated in light-catching crystals, every surface shimmering. The ice that damages is also the ice that creates temporary beauty, reminding us that nature's forces are indifferent to our categories of good and bad. Derechos are widespread, long-lived windstorms associated with a band of rapidly moving showers or thunderstorms. The name comes from the Spanish word for straight, because unlike tornadoes' rotating winds, derecho winds blow in one direction. In May 2024, a rare southern derecho event produced winds exceeding 100 miles per hour from Texas to Florida, ripping through downtown Houston and blowing out windows in skyscrapers. December 2021 saw the first December derecho on record in the United States, proving that even weather patterns can surprise us. Yet these winds are simply air rushing from high pressure to low pressure, obeying the fundamental drive of the atmosphere to equalize, to balance, to smooth out differences in temperature and density. Cold waves occur when frigid air masses move into regions normally experiencing warmer temperatures. In January 2024, extreme cold and snowstorms swept across Canada, bringing temperatures far below normal and creating challenging conditions. Arctic air masses can plunge as far south as Florida, causing freezing temperatures that affect citrus crops and challenge people unaccustomed to such cold. Yet these cold snaps are simply the atmosphere's way of redistributing heat. Warm air moves toward the poles. Cold air slides toward the equator, and the planet's temperature differences gradually even out. The atmosphere has been performing this dance for billions of years, moving air, adjusting temperatures, seeking equilibrium. Cold waves are just one part of that endless, patient balancing act. So, yes, natural disasters are already showing us that our planet operates according to forces far older and larger than human civilization. We've explored volcanic pressure releases, tectonic plates grinding, hurricanes balancing heat, floods distributing water, and wildfires renewing landscapes. Each of these events follows physical laws that have governed Earth for billions of years. The ground shakes because rocks break. Storms form because air moves. Water flows because gravity pulls. Nothing happens arbitrarily. There is no malice in a hurricane, no anger in an earthquake. These are simply the mechanisms by which our planet maintains its internal balance, releases its accumulated energy, and continues the slow transformations that have been occurring since Earth first cooled from a molten sphere spinning in space. The forces continue, patient and unstoppable. Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell inside. Trillions of organisms working in silence, heart beating, lungs breathing, brain thinking, all without your command. Notice the gentle sensations on your skin, in your muscles, along your spine. You are a complete ecosystem, diverse, self-balancing, just like Earth itself, always adjusting, always seeking equilibrium. Now we continue. Plate boundaries come in three basic types, each producing different geological features. At divergent boundaries, plates move apart, allowing magma to rise and create new crust. This is happening along the mid-Atlantic ridge, slowly pushing Europe and North America farther apart. At convergent boundaries, plates collide, with one often sliding beneath the other in a process called subduction. This creates the deep ocean trenches and volcanic arcs of the Pacific Ring of Fire. At transform boundaries, plates slide past each other horizontally, grinding and catching. The San Andreas Fault in California is a famous example. Each boundary type has its own characteristic earthquakes, volcanoes, and landscape features. The boundaries are where Earth's internal heat escapes most readily. Earthquake magnitude is measured on a logarithmic scale, meaning each whole number increase represents about 32 times more energy released. A magnitude 7 earthquake releases roughly 1,000 times more energy than a magnitude 5. The largest earthquake ever recorded was a magnitude 9.5 in Chile in 1960. In 2024, a magnitude 7.5 earthquake struck Japan's Noto Peninsula on New Year's Day, followed by dozens of strong aftershocks. These aftershocks occur because the main quake doesn't release all the accumulated stress at once. Surrounding rocks continue to adjust for days, weeks, or even years afterward, settling into their new configuration. The ground continues trembling long after the major shaking stops. Subduction zones are where oceanic plates dive beneath continental plates, sinking back into the mantle. This process pulls carbon from the surface into Earth's interior, helping regulate the planet's climate over millions of years. The Cascadia subduction zone off the Pacific Northwest coast is capable of producing magnitude 9 earthquakes, though the last one occurred in 1700, over 300 years of stress accumulating. Indigenous oral histories, however, preserved stories of the land shaking and the ocean retreating, then rushing back. Memories passed down through generations. The zone remains locked now, building stress that will eventually release. It's not a question of if, but when. The plates continue their patient push. Volcanic eruptions vary tremendously in size and violence. Some, like Hawaii's Kilauea, produce gentle lava flows that move slowly enough for people to walk away. Others, like Mount St. Helens in 1980 or Mount Vesuvius in 79 AD, explode with tremendous force, sending ash columns miles into the sky. The difference depends on the magma's composition and gas content. Magma rich in silica is thick and sticky, trapping gas bubbles that build a pressure until violent eruption. Magma poor in silica flows more easily, allowing gases to escape gradually. Both types are just molten rock rising toward the surface, but their chemistry determines whether they whisper their way out or shout. Hurricane intensity depends on several factors. Warm ocean water provides fuel. Low wind shear allows the storm to develop vertically, and moisture in the atmosphere feeds the system. Hurricane Milton in October 2024 underwent rapid intensification, reaching Category 5 status with 180-mile-per-hour winds and a central pressure of 897 millibars, one of the lowest pressures ever recorded. An environment of enhanced wind shear weakened it before landfall, sparing some areas from the worst impacts. These storms are incredibly sensitive to atmospheric conditions. Small changes in any factor can dramatically alter a hurricane's strength. The systems are powerful yet delicate, responsive to environmental variations in ways meteorologists are still learning to predict. Flash floods occur when rainfall rates exceed the ground's ability to absorb water. In October 2024, Roswell, New Mexico experienced rainfall at rates of 1 to 3 inches per hour, transforming normally dry channels into raging torrents within minutes. Flash floods are particularly intense in desert regions, where hard-packed soil and lack of vegetation mean almost all rainfall becomes runoff immediately. Water seeks the lowest point, flowing downhill with tremendous force, carrying debris, vehicles, even buildings in its path. Yet this same water, if it fell more slowly over weeks, would be celebrated as life-giving rain. The transformation comes not from the water itself, but from its sudden arrival. Timing makes the flood. Atmospheric rivers are long, narrow corridors of concentrated water vapor in the atmosphere, sometimes called rivers in the sky. They can carry moisture equivalent to 15 times the flow of the Mississippi River. When these rivers make landfall, they can deliver enormous amounts of precipitation in very short periods. California's most significant floods often result from atmospheric rivers, and the state depends on them for much of its annual water supply. They're not good or bad, they're essential. Without them, reservoirs wouldn't fill, crops would fail, and drought would dominate. But when multiple atmospheric rivers arrive in quick succession, or when they stall over one location, the land can't absorb all that moisture. Tornado formation requires specific conditions: a layer of warm, moist air near the surface, overlain by cooler, drier air aloft, and wind shear, winds changing direction and speed with height. These conditions are most common in the central United States during spring, when warm air from the Gulf of Mexico meets cold air from Canada. The infamous Tornado Alley from Texas to Nebraska sees the most tornadoes, but they can form anywhere conditions align properly. In 2024, tornadoes occurred in China, South Africa, India, Indonesia, Mexico, and Russia. Proving this phenomenon isn't limited to America. Spinning air is simply what happens when atmospheric conditions meet in precisely the wrong or right way, depending on your perspective. Lightning creates thunder. The electrical current of a lightning bolt heats the air it passes through to about 50,000 degrees Fahrenheit, 5 times hotter than the sun's surface. This extreme heating causes the air to expand explosively, creating a shock wave we hear as thunder. Light travels much faster than sound, so we see the flash before hearing the boom. By counting seconds between flash and thunder, then dividing by 5, you can estimate how many miles away the lightning struck. That rumbling boom isn't anger. It's just air expanding faster than sound can propagate. A percussion instrument played by electricity itself. Drought develops slowly, often beginning with below normal precipitation that gradually depletes soil moisture, reduces stream flow, and lowers groundwater levels. Unlike hurricanes or tornadoes that announce themselves dramatically, drought creeps in quietly. Farmers notice it first. Seeds don't germinate. Crops wilt earlier than usual. Irrigation wells require deeper pumping. By the time drought is officially declared, its effects have already rippled through ecosystems and communities. Recovery is equally slow. A single heavy rainstorm doesn't end a drought. It takes months or years of normal precipitation to replenish aquifers and restore soil moisture. Drought reminds us that water moves slowly through Earth's systems, patient in both its departure and return. Wildfire behavior depends on three factors: fuel, weather, and topography. Dry vegetation provides fuel. Hot temperatures and low humidity make that fuel more flammable, and wind carries flames to new fuel. Topography matters because fire travels faster uphill. Heat rises, pre-warming and drying vegetation above the flames. A fire moving uphill can double or triple its rate of spread. The Park Fire in California during July 2024 ignited by arson, rapidly spread to 430,000 acres, destroying over 700 structures. Yet, for all its intensity, the fire was simply following physical principles. Heat seeks fuel. Flames follow oxygen. Energy moves from high concentration to low. Fire is chemistry in motion. Combustion releasing energy stored in plant tissues. Landslides move when the downslope force of gravity exceeds the resistance of friction and cohesion, holding material in place. Adding water reduces friction between particles and adds weight, often triggering slides. In India's Wayanad region during July 2024, heavy monsoon rains triggered landslides that affected entire communities. The soil had been stable for decades or centuries, held by tree roots and internal bonds. But deforestation weakened those natural anchors, and intense rainfall added the final destabilizing force. The landslide wasn't sudden from Earth's perspective. Forces had been shifting toward instability for years. The slide itself was simply the moment when opposing forces reached a tipping point, and gravity prevailed. Heat waves occur when high-pressure systems stall over a region, trapping hot air near the surface like a lid on a pot. Clear skies under high pressure allow intense sunshine to bake the ground, which radiates heat back into the air. Nighttime temperatures don't fall enough for recovery, so heat accumulates day after day. Urban areas experience more intensity than rural areas because concrete and asphalt absorb and retain heat better than vegetation. This urban heat island effect can make cities 10 to 15 degrees warmer than surrounding countryside. The heat wave isn't attacking. It's simply air sitting still, absorbing solar energy with nowhere to move, no cooler air to mix with. Ice ages occur when Earth's orbit and axial tilt change slightly over thousands of years, altering how much sunlight different parts of the planet receive. These are called Milankovitch cycles, after the scientist who described them. During ice ages, massive ice sheets cover continents. Sea levels drop hundreds of feet, and global climate cools dramatically. We're currently in an interglacial period, a warm phase between ice ages. The last major ice age ended about 11,000 years ago. During its peak, ice sheets covered Canada and reached as far south as New York City. The climate changes weren't caused by disasters. They were the natural result of planetary orbital mechanics, gravity's subtle dance playing out over millennia. These observations reveal that natural disasters are not random events, but predictable consequences of Earth's physical processes. Plates move because convection currents flow in the mantle. Hurricanes form because warm ocean water evaporates and releases energy. Floods occur when rainfall exceeds absorption. Each disaster is simply matter and energy following universal laws. Gravity pulls, heat flows, pressure equalizes. There is no chaos in these systems, only complexity. The patterns are there if we look closely enough. Earthquakes concentrate along plate boundaries. Hurricanes form over warm tropical waters. Tornadoes emerge when atmospheric layers clash. Understanding these mechanisms doesn't make disasters less powerful, but it does make them less mysterious. Nature isn't unpredictable. We're still learning its language, still deciphering the grammar of geology and atmosphere. You're still here with me, thoughts still drifting through Earth's ancient patterns. Take a slow breath. Notice how your body feels heavier now, as if gravity itself is gently pulling you deeper into rest. We're wandering through nature's quiet wisdom together, you and I and everyone listening in the soft dark. There's no rush, no destination, just the gentle rhythm of understanding carrying us forward. Let's continue. Earth's internal heat comes from two sources: leftover warmth from the planet's formation 4.6 billion years ago, and ongoing radioactive decay in the core and mantle. Elements like uranium, thorium, and potassium break down slowly, releasing energy that keeps Earth's interior molten. Without this internal heat, plate tectonics would cease. Volcanoes would go silent, and magnetic fields would collapse. The disasters we experience are side effects of a living, dynamic planet. A geologically dead world like Mars has no earthquakes, no erupting volcanoes, and no protective magnetic field, no recycling of nutrients, no climate regulation. Our planet's heat powers both its dangers and its habitability. Continents drift because Earth's mantle, though solid rock, flows slowly over geological time like extremely thick honey. Heat from below causes convection currents. Warm material rises, cools near the surface, then sinks again, pulling the plates along. The Atlantic Ocean is currently widening at about 2 inches per year, pushing Europe and North America farther apart. The Pacific Ocean is shrinking at about the same rate as plates subduct beneath Asia and the Americas. In 200 million years, Earth's continents may merge again into a new supercontinent, as they've done repeatedly throughout Earth's history. The dance of the continents continues, patient and inevitable. Hurricanes form only between latitudes of about 5 and 20 degrees north or south of the equator. They can't form directly at the equator because Earth's rotation doesn't provide enough spin. The Coriolis effect is zero at the equator. They rarely form above 20 degrees latitude because ocean waters are generally too cool. This narrow band of hurricane formation explains why some coastal regions experience frequent tropical cyclones, while others, just a few hundred miles away, remain safe. The hurricanes aren't targeting specific areas. They're simply obeying the constraints of physics and geography, forming only where conditions permit their birth. Earthquake aftershocks occur because the main quake doesn't release stress evenly. Some areas release completely, while others release partially, and still others gain new stress transferred from the ruptured zone. These partially stressed areas continue breaking in smaller earthquakes, aftershocks, that can continue for months or years. The largest aftershock is typically about 1 magnitude unit smaller than the main shock. After a magnitude 7 earthquake, expect a magnitude 6 aftershock. In rare cases, a large aftershock can trigger an even larger earthquake, though scientists then reclassify the first event as a foreshock. The ground is still settling, still adjusting to its new configuration, finding stability through continued small movements. Volcanic hotspots occur where plumes of abnormally hot mantle rock rise from deep within Earth. The Hawaiian Islands formed as the Pacific Plate moved over a stationary hotspot, creating a chain of volcanoes that gets progressively older to the northwest. The Big Island of Hawaii, currently over the hotspot, has active volcanoes. Islands to the northwest are progressively older and more eroded, their volcanoes long extinct. Eventually, the Big Island will move off the hotspot. Its volcanoes will cease erupting, and a new island will form to the southeast, a process that has been creating and destroying islands for millions of years. The hotspot stays put. The plate keeps moving. Lightning strikes follow the path of least resistance between cloud and ground. Tall objects like trees, buildings, and lone standing people provide easier paths than flat ground because they reduce the distance lightning must travel through insulating air. Benjamin Franklin proved this in 1752 with his famous kite experiment, demonstrating that lightning is electricity and can be guided safely into the ground through conducting rods. Today's lightning rods work on this principle, providing a preferred path that protects structures. The lightning doesn't choose to strike the tallest object. It simply follows the physics of electrical resistance, taking whichever route requires the least energy to travel. Drought occurs when weather patterns shift, causing persistent high-pressure systems that prevent rain clouds from forming. In 2024, parts of Texas, Oklahoma, and Kansas experienced severe drought with significant crop impacts. The Kariba Dam in Zambia saw water levels drop so low it couldn't generate full power. These aren't isolated events. They're connected to larger atmospheric circulation patterns. Changes in ocean temperature thousands of miles away can shift where storms form and where they don't. El Niño and La Niña events in the Pacific Ocean influence weather globally, bringing drought to some regions while flooding others. Water hasn't disappeared. It's simply been redistributed, falling elsewhere, cycling through different parts of the planet's water system. Wildfires serve ecological purposes. Many tree species have evolved to depend on fire for reproduction. Jack pine and lodgepole pine cones are sealed with resin that only melts in intense heat, releasing seeds after fire has cleared the ground. Giant sequoia bark is fire-resistant, and their cones also open after fire. Some ecosystems actually decline without periodic fire. Ground cover becomes too dense, blocking sunlight from reaching the forest floor, preventing new tree seedlings from establishing. Native Americans understood this, using controlled burns to maintain healthy forests and grasslands. The fires we call disasters are sometimes ecosystems trying to correct long periods without fire, decades of accumulated fuel burning at once. Floods deposit sediment that renews soil fertility. The annual flooding of the Nile River, before the Aswan Dam controlled it, brought nutrient-rich silt from upstream, fertilizing farmland that fed ancient Egyptian civilization for thousands of years. Many of the world's most productive agricultural regions are river floodplains. Yet, modern development has placed cities and farms in these naturally flooding areas, creating conflicts between human infrastructure and rivers simply doing what rivers have always done. The floods haven't become more intense. We've simply built more things in the path of water following gravity to the sea. Halfway through our journey, The answer is emerging. Natural disasters happen because Earth is alive with energy. This energy comes from its molten interior and from the sun's radiation. The planet must release this energy, must move this heat around, must balance temperatures between equator and poles. If Earth were geologically dead, it would be lifeless like Mars. No atmosphere to speak of, no water cycle, no nutrient recycling. The forces that occasionally affect human structures are the same forces that make this planet habitable. Plate tectonics recycles carbon. Volcanoes create new land and release essential gases. Hurricanes distribute heat. Floods spread nutrients. The disasters are inseparable from the systems that make Earth home. The planet breathes, and sometimes we're in the path of that breath. Let each breath guide you to realize time is yours, a separate stream that only you are living. While vast forces continue to shift, weather patterns evolve, plates drift beneath oceans. This second you're breathing, listening, is unique. Cherish the present moment, knowing that right now, your time flows at its own pace. Even as Earth keeps turning, storms keep forming, tides keep rising and falling. You exist in this single, quiet moment. And we continue drifting. Earth's magnetic field is generated by the motion of molten iron in the outer core. This field extends thousands of miles into space, forming a protective bubble that deflects harmful solar radiation. Without it, solar wind would gradually strip away our atmosphere, as happened to Mars billions of years ago. This same magnetic field causes compass needles to point north, guides migrating birds, and creates the aurora borealis when solar particles interact with atmospheric gases. The magnetic field is a side effect of Earth's liquid core, which exists because the planet retained enough internal heat. That heat also drives plate tectonics. The water cycle is driven entirely by the sun's energy. Solar radiation evaporates water from oceans, lakes, rivers, and soil. This water vapor rises, cools, and condenses into clouds. When droplets grow large enough, they fall as rain or snow. Some soaks into the ground, some flows to the ocean, some is absorbed by plants. Plants release water back to the atmosphere through transpiration. The entire cycle, evaporation, condensation, precipitation, collection, continues endlessly, powered by sunlight. Floods and droughts are simply variations in this cycle's timing and location. The total amount of water never changes, only its distribution across Earth's surface. Mountains form through tectonic forces over millions of years. The Himalayas continue growing about half an inch per year as the Indian plate pushes into the Eurasian plate. Mount Everest, measured at 29,032 feet, is still rising, though erosion constantly works to tear it down. Rain dissolves minerals, freeze-thaw cycles crack rocks, plant roots wedge into crevices. Eventually, all mountains return to sediment in the sea. Then, through plate tectonics, that sediment may be compressed, uplifted, and formed into new mountains. The cycle of creation and destruction operates on timescales that dwarf human civilization. Glaciers are rivers of ice that flow downhill under their own immense weight. They may move only inches per day, but over time they carve valleys, transport boulders, and reshape entire landscapes. During the last ice age, glaciers covered much of North America, carving out the Great Lakes and leaving behind the fertile soils of the Midwest when they melted. Glaciers still cover about 10% of Earth's land surface, holding roughly 69% of the world's fresh water. If all glaciers melted, sea level would rise about 230 feet. These massive ice sheets are not frozen and static. They flow, calve, advance, retreat. Coral reefs are built by tiny animals that extract calcium from seawater to create protective skeletons. Over thousands of years, these skeletons accumulate into massive reef structures. Australia's Great Barrier Reef, visible from space, is the largest living structure on Earth. Reefs provide habitat for 25% of all marine species. They also protect coastlines from storm surge and erosion. When ocean temperatures rise too much, corals expel their symbiotic algae and turn white, a stress response called bleaching. Prolonged bleaching can affect coral health. Reefs show us that even powerful forces have limits, thresholds beyond which systems change. Soil formation takes centuries. Rock must weather into smaller particles. Organic material must decompose. Fungi and bacteria must establish networks. A single inch of topsoil can take 500 years to form. Yet erosion can remove that inch in a single storm if vegetation is removed. Ancient civilizations declined when they lost their topsoil to erosion. The Dust Bowl taught Americans this lesson during the 1930s. Soil isn't just dirt. It's a living ecosystem, home to more organisms than all humans on Earth. Without soil, terrestrial life cannot exist. It's Earth's skin, thin and precious. Ocean currents transport heat around the globe, moderating climate. The Gulf Stream carries warm water from the Caribbean to northern Europe, making Britain's climate far milder than it would be at its latitude. Without this current, London would have winters like Winnipeg, Canada. These currents are driven by differences in water temperature and salinity, and by prevailing winds. El Niño events occur when these patterns shift, warming the eastern Pacific and altering weather worldwide. Ocean currents have been flowing for millions of years, redistributing heat, enabling life in unexpected places, connecting distant shores through moving water. The atmosphere is layered, with different properties at different altitudes. The troposphere, where weather occurs, extends about 7 miles up. Above that, the stratosphere contains the ozone layer that absorbs harmful ultraviolet radiation. Higher still, the mesosphere, thermosphere, and exosphere gradually transition to space. Hurricanes cannot penetrate above the troposphere. Their tops flatten against the stratosphere's stable air like smoke spreading against a ceiling. Each atmospheric layer plays a role in making Earth habitable. The thin envelope of air protecting us is precious, only about 60 miles thick on a planet 8,000 miles in diameter. Lightning strikes create nitrogen compounds that fertilize the soil. The electrical discharge is so energetic it breaks apart nitrogen molecules in the air, allowing them to combine with oxygen. These compounds dissolve in rainwater and fall to Earth, where plants absorb them. Before humans developed synthetic fertilizers, lightning was a significant natural source of nitrogen for ecosystems. An estimated 100 million tons of nitrogen are fixed by lightning globally each year. The same force that can affect dramatically can also nourish. Lightning doesn't discriminate. It simply transforms the atmosphere through raw energy. Tide cycles are caused by the moon's gravity pulling on Earth's oceans. As Earth rotates, different regions pass through bulges of water, experiencing high and low tides twice daily. The sun's gravity also influences tides, but less so because it's much farther away. During new and full moons, when sun and moon align, tides are higher, spring tides. During quarter moons, when they pull at right angles, tides are smaller, neap tides. These cycles have governed coastal life for billions of years. Creatures evolved to match them, spawning and feeding according to tidal rhythms older than any continent. Permafrost is ground that remains frozen for at least 2 consecutive years. It covers about 24% of the northern hemisphere's land surface. Buildings, roads, and pipelines built on permafrost can face challenges if the ground thaws. Some permafrost has been frozen for hundreds of thousands of years, containing Ice Age plants, animals, and air bubbles from ancient atmospheres. Scientists study these frozen time capsules to understand past climates. As global temperatures rise, some permafrost is thawing, releasing methane, a potent greenhouse gas trapped for millennia. The frozen ground is Earth's deep freezer, preserving ancient history. Wetlands act as natural sponges, absorbing floodwater and releasing it slowly. They filter pollutants, recharge groundwater, and provide habitat for countless species. Yet humans have drained over half of the world's wetlands for agriculture and development. This increases flood risk. Without wetlands to absorb excess water, rivers overflow more quickly and dramatically. Natural systems engineered flood control over thousands of years. When we remove them, we lose their services and must build expensive substitutes that rarely work as well. Wetlands are Earth's kidneys and buffers, essential for healthy water systems. Sand dunes are sculptured by wind, grain by grain. Each sand particle is bounced along, too heavy to stay airborne, but light enough to move. Dunes form specific shapes depending on wind patterns. Crescent dunes, where wind blows from one direction. Star dunes, where winds shift. Linear dunes, where winds are strong. The Sahara Desert contains dunes over 500 feet tall. Yet these massive structures migrate slowly across the landscape, driven by persistent winds. What seems permanent is actually flowing. Solid earth, behaving almost like liquid under wind's patient force. Stone rivers, moving too slowly to see. Tree rings record climate history. Each year, a tree adds a new growth ring. Wide rings in good years with ample water. Narrow rings during droughts. Scientists can count back hundreds or thousands of years in old trees, reconstructing past climates. Some bristlecone pines in California are over 5,000 years old, their rings chronicling weather patterns since before the pyramids were built. Trees remember when humans have forgotten. They stand as witnesses to centuries of drought and rain, fire and flood, quietly recording in their wood the story of Earth's moods. We now understand that Earth's systems are interconnected. Forests influence rainfall patterns. The Amazon generates half its own rain through evapotranspiration. Ocean temperatures affect atmospheric circulation. Ice reflects sunlight, keeping polar regions cool. Plankton produce half the oxygen we breathe. Remove any component, and other systems adjust. These feedbacks can be stabilizing or changing. For most of Earth's history, stabilizing feedbacks dominated, keeping the planet habitable through massive changes. Systems follow physical laws to wherever those laws lead. The planet operates according to cause and effect, action and reaction, energy in and energy out. Earthquakes release energy that has accumulated for decades or centuries. The longer the time between earthquakes on a given fault, generally, the larger the eventual earthquake will be. The Cascadia subduction zone hasn't had a major earthquake since 1700, over 300 years of stress accumulating. When it finally releases, it will likely be magnitude 8 or 9. This isn't a prediction of doom. It's simply physics. Strain builds at a measurable rate. Eventually, friction yields. The earthquake will come because it must, because the plates haven't stopped moving, because Earth hasn't finished its long, slow dance. Volcanic eruptions have sometimes cooled the planet. In 1815, Mount Tambora in Indonesia erupted so intensely it sent massive amounts of ash and sulfur dioxide into the stratosphere. This material circled the globe, reflecting sunlight back to space. The following year, 1816, was called the year without a summer. Crops failed across Europe and North America. Snow fell in New England in June. The same forces that transform locally can affect globally. A single volcano can alter weather worldwide for years. The planet's systems are connected in ways we're still discovering. Causes and effects separated by oceans and years. Ocean acidification occurs as seawater absorbs carbon dioxide from the atmosphere. The CO2 reacts with water to form carbonic acid, lowering pH. This makes it harder for corals, shellfish, and other creatures to build calcium carbonate shells and skeletons. The ocean has been absorbing about 30% of human-released carbon dioxide, slowing atmospheric warming, but changing ocean chemistry. The last time ocean pH changed this rapidly was 55 million years ago. Many species faced challenges adapting. The ocean is still absorbing, still changing, following chemistry's relentless equations. Monsoons are seasonal wind patterns that bring heavy rains to tropical and subtropical regions. During summer, land heats faster than ocean, creating low pressure over continents. Moist ocean air rushes in, bringing torrential rains. Billions of people depend on monsoons for agriculture and fresh water. Yet too much rain brings floods. Too little brings drought. The 2024 Wayanad landslides in India were triggered by intense monsoon rainfall. Monsoons have governed Asian life for millennia. Civilizations rose and fell according to their reliability. The winds return every year, sometimes gently, sometimes intensely. Ice sheets contain records of ancient atmospheres. As snow accumulates and compresses into ice, tiny air bubbles are trapped. Scientists drill ice cores in Greenland and Antarctica, extracting ice up to 800,000 years old from deep cores. Some special sites preserve even older ice, up to 2.7 million years, offering glimpses into Earth's distant past. The air bubbles preserve samples of ancient atmosphere, allowing direct measurement of past carbon dioxide, methane, and other gases. Ice cores show that current atmospheric CO2 is higher than any time in the last 800,000 years. The ice remembers what we never knew. Avalanches can travel at 80 miles per hour, descending mountains in minutes. The mass of moving snow creates its own wind, snapping trees and affecting buildings. Yet avalanches also redistribute snow, filling valleys, creating meltwater sources for spring and summer. Mountain communities have learned to predict avalanche risk through careful observation of snowpack layers, weather patterns, and terrain. Some trigger controlled avalanches to prevent larger ones. They've learned to coexist with gravity and snow, reading the mountain's signals, respecting the power of frozen water set in motion down steep slopes. Tornadoes are rated on the enhanced Fujita scale based on damage, not directly on wind speed. EF0 tornadoes cause minor damage, broken branches, damaged signs. EF5 tornadoes, the strongest and level well-built homes and throw vehicles hundreds of yards. Fewer than 1% of tornadoes reach EF5 intensity. Most tornadoes are relatively weak and short-lived, touching down briefly in unpopulated areas. The massive wedge tornadoes that dominate news coverage are exceptions. Most are thin, brief, causing little damage. The tornado is just rotating air, usually more sound than fury. River deltas form where rivers meet the sea, depositing sediment carried from upstream, the Nile, Mississippi, and Ganges deltas are among Earth's most fertile agricultural lands built from millennia of flooding. Yet deltas are sinking as dams upstream trap sediment. While sea level rises, cities built on deltas face increasing flood risk. The delta is caught between river that no longer replenishes it and ocean that rises toward it. These productive lands, home to hundreds of millions, exist in dynamic balance between two powerful forces. Lightning happens about 100 times per second globally, 8 million strikes per day, 3 billion per year. Most occur in tropical regions where warm, moist air rises vigorously. Central Africa has the highest lightning density on Earth. Florida experiences more lightning strikes than any other U.S. state. Yet lightning impacts have declined dramatically, about 20 per year in the U.S. now, compared to over 400 per year in the early 1900s. We've learned to come inside during storms to avoid open fields, tall trees, water. We've adapted our behavior to respect electricity's power. Earth's systems aren't isolated. Ocean currents connect distant shores. Atmospheric circulation moves weather globally. Plate tectonics cycles materials between surface and deep interior. Everything connects. A volcanic eruption in Indonesia affects European crops. A hurricane in the Caribbean delivers moisture to North America. Nothing happens in isolation. The planet is a single, integrated system, each part affecting all others. Natural disasters remind us of these connections. They're moments when distant forces suddenly converge in one place, when the invisible threads linking air, water, and rock become visible. When we remember that everything on Earth touches everything else. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles and the forces. Water flows downhill because gravity pulls. Heat rises because density shifts. Plates move because convection flows. Everything follows laws written at the universe's beginning. Like your breath, inhale, exhale, inhale, exhale. A small physics experiment within the vast cosmos. You don't need to understand everything. Just feel the gentle pull of natural law, like Earth itself, always adjusting, seeking balance. We're almost there now. Natural disasters are Earth speaking its only language, the language of physics, of matter and energy seeking balance. Rocks break because stress exceeds strength. Water flows because gravity pulls. Air moves because pressure differs. These aren't tragedies from the planet's view. They're necessary adjustments, energy releases, rebalancing acts. We call them disasters because we happen to be standing where these forces meet. But the forces were there first, operating for billions of years before we arrived. They'll continue long after we're gone, patient and impersonal as mathematics. Consider this. A planet without earthquakes would be a planet without mountains, without volcanoes, no new land, without weather, no rain to fill rivers and lakes, without floods, no fertile deltas. The forces that occasionally transform are the same forces that create. You cannot have one without the other. Life evolved on an active planet, adapting to its rhythms, finding niches in the spaces between changes. We exist because Earth is dynamic, not despite it. Stillness would mean lifelessness. The Kariba Dam generated electricity because water accumulated behind it. But water only accumulated because the Zambezi River flowed, and the river flowed because rain fell in highlands, and rain fell because the water cycle moved moisture inland. That same water cycle can deliver drought or flood. The dam doesn't eliminate these variations. It only stores water temporarily, buffering extremes. We build infrastructure to work within nature's patterns. Understanding constraints the planet sets. The river continues flowing according to ancient rhythms. Hurricane forecasting has improved dramatically. In the 1960s, storm track predictions were off by an average of 350 miles at 48 hours. Today, they're accurate to within 75 miles. We've learned to read atmospheric patterns, to track warm water, to measure wind shear. We can warn people days in advance. The hurricanes haven't become weaker, but we've become better at understanding them. Knowledge softens impact, even when we can't prevent the storms themselves. Earthquakes cannot be prevented, but their effects can be reduced. Building codes requiring flexible structures have saved countless lives. Japan's buildings sway during earthquakes rather than collapse. Early warning systems detect initial waves and send alerts before stronger waves arrive. Sometimes only seconds of warning, but seconds enough to take cover. We've learned to bend where we cannot stop the force, to adapt, to respect forces we cannot control. Coral reefs provide a natural storm barrier, reducing wave energy by up to 97%. Healthy mangrove forests protect coastlines from storm surge and erosion. These natural defenses are more effective and far cheaper than seawalls and levees. Yet, we've removed over half of the world's mangroves and coral reefs. When storms arrive, effects are more intense. Nature had engineered protections. Understanding their value helps us preserve what remains. Wetlands filter water, absorb floods, and store carbon. Forests create rainfall, stabilize soil, and provide windbreaks. Healthy ecosystems provide services worth trillions of dollars. But these services are invisible until they're gone. After clearing forests, hillsides slide. After draining wetlands, floods intensify. After warming oceans, hurricanes strengthen. The connections become obvious only after they're severed. Nature's systems evolved over millions of years. Understanding them helps us make wiser choices. Indigenous peoples lived in regions experiencing natural forces for thousands of years through deep environmental knowledge. They knew which areas flood, which slopes avalanche when hurricanes arrive. They built accordingly, moved seasonally, read weather signs. Much of this knowledge was overlooked when colonization dismissed it. Now we're relearning lessons preserved through countless generations observing nature's patterns. Traditional ecological knowledge offers wisdom earned through patient attention to Earth's cycles. The 2004 Indian Ocean tsunami affected over 230,000 people. But some indigenous groups in the Andaman Islands survived because they recognized warning signs: the sudden retreat of water, the earthquake's unique motion, and moved to high ground. Animals also fled inland before the waves arrived. Nature provided warnings for those who knew how to read them. Modern warning systems now mimic these natural signals, translating Earth's language into sirens and alerts. So natural disasters have changed how we understand Earth. We now see our planet as an integrated system where everything connects. We understand that attempting to control nature often brings unexpected results. We recognize that living safely means adapting to natural rhythms rather than fighting them. The forces teach us humility, reminding us that human civilization is brief, dependent on systems we didn't create and cannot command. The planet continues its processes, following physics, indifferent to our plans. The real question isn't why disasters happen. It's about understanding where natural forces have always been active. Rivers have flooded their banks for millions of years, depositing nutrients and reshaping landscapes. Fault lines mark where Earth's plates meet, zones of movement that predate human civilization by billions of years. Our choices about where to build determine our relationship with these ancient patterns. Understanding geography means understanding risk, finding harmony between human needs and planetary realities. Earth is patient with our learning. Floods come, we rebuild. Floods return. Earthquakes strike. We construct in the same location. Earthquakes strike again. The planet repeats its lessons until we understand. Slowly, we're learning. Building codes improve. Early warning systems save lives. We're beginning to work with natural forces rather than against them. Understanding deepens with each event. Purchased at a price, but genuine nonetheless. Perhaps disasters aren't events, but revelations. Moments when Earth's constant processes suddenly affect us. The ground was always moving. Water was always cycling. Heat was always transferring. These processes suddenly intersect with human presence, and we call it disaster. But from Earth's perspective, nothing unusual occurred. Just another adjustment, another release, another cycle completing. Disaster is our name for encountering reality. The volcano erupting in Iceland creates new land even as it affects air travel. The earthquake that changes buildings also releases accumulated stress that might otherwise build to something larger. The flood that affects homes deposits nutrients in fields. Even in transformation, creation continues. Nature doesn't separate these categories. We do. The same force builds and transforms simultaneously. Our labels are human inventions overlaid on neutral processes. Astronauts looking at Earth from space see no borders, no nations, just weather patterns swirling, ocean currents flowing, continents slowly drifting. From that distance, the planet appears as it is, a single system, all parts connected. Disasters, merely redistributions of energy and matter. A hurricane is just heat being moved. An earthquake is stress being released. A flood is water following gravity. All necessary, all natural, all part of Earth being Earth. Climate changes over long timescales. Ice ages come and go. Continents merge and split. Ocean currents shift. Throughout all this, life adapts. Species migrate, evolve, or sometimes face extinction. The planet doesn't maintain conditions for any particular species. It simply follows physical laws. Life must adapt to Earth, not the other way around. This has always been true. It remains true now. We live in a fortunate time. Average global temperatures are moderate. Ice caps exist but don't cover continents. Sea levels are stable enough for coastal communities. This interglacial period has lasted 11,000 years, the entire span of human civilization. But it's temporary. Ice ages will return someday, or warming will continue. Earth will change because change is what planets do. Stability is the exception. Change the rule. The intensity of disasters fades over time, replaced by understanding. Children who experienced earthquakes eventually study geology. Survivors of floods become hydrologists. Fear transforms into curiosity, then knowledge, then acceptance. This is how humanity has always processed the incomprehensible, by learning, measuring, naming. We cannot control the forces, but we can understand them. Understanding brings a peace even when control remains impossible. Natural disasters remind us we're not separate from nature. We're part of it, subject to the same forces that shape mountains and move oceans. Our bodies contain water from the same cycle that causes floods. Our bones contain minerals from rock weathered by the same forces that trigger landslides. We are made of earth. When earth moves, we feel it, because we are it. There is strange comfort in this understanding. The earthquake that shakes your home operates by the same laws that keep your feet on the ground. The flood that threatens your town is moved by the same gravity that holds Earth in orbit. The hurricane that approaches your coast is powered by the same sun that warms your face. All connected, all physics, all part of the universe's fundamental operations. So why do natural disasters happen? Because a living planet must move, must flow, must release energy. Because matter and energy cannot remain still but must cycle, transform, seek equilibrium. Because Earth is not a static rock but a dynamic system of interacting processes. Because the same forces that make this planet habitable occasionally make it challenging. The disasters are the price we pay for living on a living world. And perhaps that's the ultimate answer. Disasters are not separate from Earth systems, but integral to them. Remove earthquakes and you remove plate tectonics, without which continents wouldn't exist. Remove hurricanes and tropical heat would never reach higher latitudes. Remove floods and rivers couldn't distribute nutrients. The forces we respect are the forces that made us possible. Life requires a dynamic planet. We cannot have Earth without its forces, cannot have life without the energy that occasionally challenges it. We must learn to live within nature's cycles, to respect its power, to build with wisdom. This is not defeat but maturity, accepting our place as one species among millions, all subject to the same laws, all carried on the same spinning rock through endless space. The ground will shake again. Storms will form over warm waters. Rivers will overflow their banks. Mountains will occasionally slide. This is certain. But knowing this, we can prepare, can build wisely, can warn each other. We cannot change Earth's nature. We can change our own, learning to live not against the planet, but with it. Natural disasters happen because Earth is alive. That same aliveness gives us oceans to swim in, mountains to climb, skies to watch, ground to walk on. The planet's dynamism makes it beautiful and powerful, nurturing and challenging. We exist in the spaces between changes, grateful for calm moments, strengthened by understanding. Earth continues its ancient processes, and we continue learning to be good guests on this restless, magnificent planet. And so, our quiet journey through Earth's forces comes to a gentle close. We began with tectonic plates grinding slowly in darkness beneath oceans, moved through hurricanes gathering energy over warm tropical waters, discovered how floods follow gravity's patient commands, and learned why mountains rise grain by grain through millions of patient years. From earthquakes releasing centuries of accumulated stress to wildfires clearing forests for new growth. From volcanic eruptions creating new land to tsunamis carrying energy across ocean basins. We've glimpsed how every force we call a disaster is simply Earth maintaining its ancient balance, releasing energy, redistributing matter, following physical laws older than continents. The planet continues its work, powerful and neutral, transforming and creating, all at once. These forces remind us that we live on a dynamic planet, one that has been reshaping itself for over 4 billion years. Much of Earth's greatest power operates quietly, plates drifting beneath our feet, storms forming over distant oceans, forces building slowly in darkness. Natural disasters teach us humility, patience, adaptation. They show us that stability is temporary, that change is the only constant, and that understanding brings peace even when control is impossible. By learning to read Earth's language, the trembling of rocks, the gathering of clouds, the rising of water, we find our place not as masters of nature, but as students of forces far older and wiser than ourselves. If these calm stories from Earth helped you breathe a little easier tonight, perhaps share them softly with someone else searching for stillness under the stars. It might be exactly what another restless mind needs to finally let go and drift. One quiet share, one peaceful night at a time. And now, in these final minutes, take the deepest breath you can, as deep as possible. Think about unity, of every drop of water in every ocean, every grain of sand on every shore, every force that shapes the world. You are not separate from these forces. When earthquakes shift the ground, they move the same atoms in your bones. When storms gather moisture, they use the same water flowing in your blood. You are made of earth. Earth is made of you. Let your entire being dissolve into the rhythm of nature, into the breath of the planet. into the space between thoughts. Prepare for deep sleep. No boundaries left between you and the world. Only peace. Only stillness. Only rest. But there's no need to do anything now. Nothing at all. You've traveled far tonight, across billions of years of Earth's history, through forces that shaped mountains and carved oceans. You can allow these thoughts to fade now, like morning mist dissolving in sunlight, leaving only peaceful calm behind. Let your breathing deepen naturally. Feel your body growing heavier, as if Earth's gravity is gently welcoming you into soft, safe ground. If sleep comes, let it carry you like a river flowing to the sea, smoothly, inevitably, into a realm where time no longer matters. Tomorrow, the plates will still be drifting, storms will still be forming, rivers will still be flowing. But tonight belongs to stillness. Rest well, weary traveler. You live on a planet that has been shaping itself for over 4 billion years. You are part of that story, brief and beautiful. Good night.